Okay, hold it, Mike. What are we doing with this new radio here? Hold it. Didn't we just say we were going to work on automatic regeneration? Well, yes, we just cut metal for automatic regeneration receiver, sort of a test bed, and I have sent that test bed back to the guy that's developing the circuit board for the auto regen. He's going to be mounting the parts in there, testing the unit, and then he'll send it back and we can evaluate it. So in the meantime, sticking with our regeneration theme, I've got a new receiver to show you. And this guy is a mystery machine. You're going to love it. Okay, first of all, where did it come from? Well, I'm a member of the New England Vintage Electronics Club. And these guys, some of them are hams, but most of them are just radio collectors and historians, people interested in radios and the history of radio, and collecting especially broadcast band style radios. And I was told that there was a gentleman in Massachusetts that had a receiver that was in a piece of furniture that he had bought when he was in college in Cornell, New York. And it had this radio inside that he never really used. Would someone be interested in this rather odd radio built into this piece of furniture? So I made the trip down there. And what I found was this very, very interesting and rare kit radio. This thing is really amazing. And it's going to take some work to figure out what we have here. This is not a normal receiver. It's obviously built professionally, but not in a factory. Okay? This is a kit receiver built by a radio technician, maybe a radio guy in town, certainly professionally wired. I think this is going to be a lot of fun to figure out what makes this receiver tick. It looks to me like it's a RF stage, a regenerative stage, and 2 stages of audio amplification. That probably places it in the mid-20s. So let's see what we got here. You know, I like the strange, the unusual, the mystery radios, and I was lucky enough to get another whiz-bang of a mystery receiver. This one is so strange, I don't even know where to start. Let's just say it's got different types of coupling and regeneration circuits. It's made in a very strange pattern of symmetry. There's no name on this receiver. This is definitely a kit or a homebrew construction, but very professional. And again, this is common in the era of the early 20s when companies wanted to either promote a product by putting a kit together for you. In this case, I believe it's the transformers. See these harmonics transformers? I think that's the company that might have put the kit together. But all the parts are very professional on this receiver. The wiring is excellent on the bottom. But again, this probably was done by a town radio man. Your radio guy in town, you'd give him this kit or tell him to order the kit, and he would build the set in his shop. Now, the other reason that these kits were very popular, these no-name kits, was it was a way to skirt the patents, the draconian patents of the day enforced by companies like, RCA and Westinghouse with Armstrong. Perhaps the regenerative patent was something that you didn't want to deal with. So if you were making a kit of parts, technically you're not violating the patent. It's being assembled by you or by your proxy assembler in town, your radio guy. So really, before I could even touch this receiver or the technology in this receiver, and it's got some pretty strange technology, we're going to need to go over some of the techniques that they use in here, including coupling and variable coupling using 2 coils. So let's go through that first. Some of you may remember this receiver that I did the video on a couple years ago. This is also a kit receiver. This is not a manufactured receiver in a factory with a factory logo or nameplate. This is another one of those kit radios that we're talking about. Let's look inside at the variable coupler that it uses for regeneration. Looking down into the regenerative set, we have a single regenerative detector and 2 audio stages. Over here we have the main tuning, and here is the regeneration control. Notice that the regeneration control uses a variable coupling mechanism. We have the main tuning coil below and the tickler coil that I'm rotating. This variable coupler, or variocoupler, is one of the ways that this Regen has such smooth regeneration control. This was built specifically for the broadcast band. So again, this is a mid-20s type kit radio. Armed with this, let's see why a variable coupling mechanism works so well. The story really begins in the 1910s with the loose coupler. This coupling mechanism, in and out, with the primary and secondary being variable, this was a great way to establish selectivity in your receiver. The slider was the way of changing inductance on one side of the transformer. The taps changing the inductance on the other side of the transformer. So the loose coupler is in effect a RF transformer where you have control over both the primary and the secondary of the coil. This one, sometimes it's called a Navy coupler. It was used for the lower frequencies, for the Marconi transmissions, the Navy transmissions, government transmissions, even time signal transmissions in the, say, tens of kilohertz up to perhaps 200 or 300 kilohertz. This is a low frequency loose coupler. Not really made for ham radio use after 1910 or 1912. In 1912, they kicked the hams out of those low frequencies, and they told them to operate at higher frequencies. And this is an example. This is also a reproduction unit. This is an amateur radio loose coupler. You can see it's much smaller. It has the same features, but this works all the way up to about 2 megahertz. So this device is used for 200 meter type operation, the higher frequencies that hams used after 1912. So when you see a small loose coupler like this, you know you're looking at an amateur radio loose coupler and not a Navy or a government loose coupler. So let's talk about the various types of coupling that came with the variable coupling, consisting of 2 different coils that rotate inside each other, one being a stator and one being a rotor. Let's look at the 3 types that we know about. So the little mystery receiver has got some pretty special looking hardware. We're going to have to go through some of the advanced hardware on this receiver. The first thing we see are those variometers. Actually, variometer is a general term. You have variocouplers and variometers, but when you say variometer, that's the general term. It really describes 2 coils, one of them being rotatable within the other. Variometers also uses a more specific term that describes the simplest use of the assembly as a one-port device, which is that of a variable inductor. Essentially, you're taking the place of a movable ferrite tuning core or a tap or slider to change the inductance value. But it's a little more complicated than that. It's not really a pure inductor. In many early lower frequency radio applications, it comprised the entire tuned circuit. It could be used as a tuning element, just like an LC resonant circuit in a receiver, a VFO, a driver stage. They relied on the distributed capacitance between the turns to achieve resonance. As you rotated the coil, the inductance changed, and this caused the resonant frequency to change. So no variable capacitors needed. The early Atwater-Kent breadboard radios used this method rather than a variable capacitor and fixed inductors. So in this 2-terminal variable inductor example, as the rotor coil is moved within the stator and the maximum inductance occurs when the 2 coils are fully aiding, like in a 2-layer solenoid coil, you get the maximum inductance.
Minimum inductance is at 180 degrees of this. At 90 degrees, you get an inductance value in the middle of the range, equal to the two inductors' value in series. This application as a variable inductor requires that the two windings are connected in series aiding for phase initially. The general schematic symbol looks like this. The result is a single rotary controlled variable inductance with no taps or sliding contacts. However, the stator winding could be tapped for even more flexibility and band coverage. This was also a very powerful component when used in the output tank of a transmitter or in an antenna tuner. For instance, the Collins ART13 transmitter uses a variometer in its pi filter output tank. The most common term for this component, again, is variometer, even though variometer is also a general term describing all rotating coils inside a stator winding. A simple variometer can be constructed with two chunks of PVC pipe with roughly the same amount of inductance on each one. This, of course, means more turns on the smaller diameter rotor. A spherical shape on both rotor and stator will allow closer coupling and less overall loss. Fancy windings like basket weaves and others were also employed to improve Q and extend tuning range before self-resonance. Consider rotating through 180 degrees. At 0, we might be in phase, so maximum inductance. This is the lowest frequency in a tuned arrangement, the bottom of the band. When 90 degrees apart, there's no coupling. The total inductance is simply the sum of the two inductors in series. When the rotor is at 180 degrees to the stator, the mutual coupling subtracts from the total and the inductance is close to 0. So this antiphase condition, this is usually the high end of the tuning in the band. The second type of variometer class is called the variocoupler. This is a two-port device, two wires connected to the stator, two wires connected to the rotor winding. This is a very useful device for controlling RF gain. This is used in receiver front ends, antenna couplers, impedance step up or step down, for power output adjustment, and it's used as the feedback throttle as with a regenerative receiver. In the standard construction, it goes from minimum to maximum coupling in just 90 degrees. This is because the coupling increases again past 90 degrees, but the phase flips. So in an antenna coupling duty, it would only work correctly in a 90-degree rotation. In a regen tickler, it would go from maximum coupling to minimum coupling at 90 degrees, and then actually produce negative feedback beyond 90 degrees, and the coupling would increase again. A special, more complex build variation was conceived that solved this limitation. The device was built with a 45-degree off-axis construction. This allowed the coupling to increase over a 180-degree rotation rather than in just 90 degrees. So remember that simple 3-tube regen that we had. That had a very simple regeneration control with the standard design of the variocoupler. That is, you had regeneration control over just 90 degrees. However, the mystery receiver has a more complex-looking variocoupler for regeneration control, and this allows regeneration control over 180 degrees. The special build allowed the rotor coil to move from parallel, maximum coupling, to minimum 90 degree in a dial sweep of 180 degrees without a phase change relative to the stator coil. Let's take a look.
Okay, this is a variocoupler stator, or you have to imagine it is. And I'm going to pretend that I'm the rotor with my Dixon Ticonderoga. Now, as you can see, if I was inside there, this would be maximum coupling. And I'm just going to go 90 degrees. And this is minimum coupling. I only have a range of here to here, min to max, 90 degrees, with a standard variometer design using right angle coils or nested coils. Only gives you 90 degrees of coupling control before the phase reverses. But now I've put the stator at a 45-degree angle, and I've also put the rotor at a 45-degree angle off the dial. This is minimum, 0. I'm going to rotate 90 degrees. And now another 90. As you can see, now I'm at maximum. Let's back it off again. 90. And 90 more, minimum. So I've now transitioned from a 90 degree adjustable to a full 180 degree adjustable by using this 45 degree build.
The third kind of variometer is called the goniometer. Here you normally see two stator windings that are oriented at right angles, or 90 degrees apart. This is a 3-port device. It could even be an N-port device with many more stators. Consider a loop antenna with a rotor or hand azimuth wheel, as with a radio direction finder. It's a rotating loop. If rather two fixed-oriented loops were erected at right angles on east-west and let's say north-south, this is known as cross loops. And these could be each connected to one of those stator windings. The third port, which is the rotating coil within, would serve to mimic the rotation of a single loop antenna. So you're rotating the loop antennas without actually rotating the physical loops. This phase and amplitude summation system also works with sets of vertical antennas, as with a Watts and Watt type radio direction finder. Even more elaborate goniometers with multiple stators were conceived to service large circular arrays of loops, long wires, and verticals. This is known as beamforming.
Okay, so before I attempt to do any work on this receiver, I'm going to have to figure out what's going on with the schematic. Reverse engineering is tough. I tried pretty hard to find information on this receiver to give me a hint on where it came from, what's the original design. Was it a famous design that simply was made into a kit? Or is this thing really something pretty special that came out of a small lab? We've really got to figure out what's going on with this receiver. We know that it has some pretty advanced techniques for regenerative receivers. And remember, regens by the mid-20s were starting to fall out of favor. The 3 dialers were really what people wanted. And by 3 dialers, I mean, your classic TRF receivers of the 1920s. Later on, super heterodynes would come in a big way. People wanted to have 1-dial tuning. This little receiver over here, you guys might have seen this one. This guy over here is an example of a 1929 TRF, a late TRF. Has a single tuning dial and a 3-gang TRF capacitor. That's what people wanted, a single tuning dial. Of course, the super heterodyne would get you there much later, where it was affordable for people. Late 20s into early 30s, the superhets really came along with great features like automatic gain control. But this regen, again, looking at this regen, we're talking about an era where the regen still gave you the most for your money, the most bang for the buck, so to speak. With 4 tubes, you could drive a speaker. People wanted to save money. 4 tubes is better than 6 tubes. 2 tubes is better than 3 tubes. The era of the reflex receiver had pretty much already passed, but the reflexive receiver was still alive and well in the experimenter and low-cost receiver market in the mid-20s. So where you see these kits is in the cut sheets and the low-cost paper-type radio periodicals, not as much in the high-class radio magazines. There you saw the real manufactured receivers, but the kits showed up in a lot of the flyers and a lot of the dealers' flyers. These kits were very, very popular, and it was a way to save money, perhaps half the price of a fully built receiver.